For the next bit of code that we're going to add, it has to do with the LED's brightness, and that is controlled through pulse width modulation. So if you remember at the beginning of this project, I gave you a brief explanation of what pulse width modulation was, and if you notice these sharp, like these high marks here, the hills, if you want to call them, that's where it's on. That's where you have 5 volts, and then the low parts, the valleys. Let me add more to this. That's where it's off. Notice that there's no slope. It just goes straight from on to off. Okay? And over a fixed period of time, this will cycle on and off. And the percentage of time that this is on, that's what's called the duty cycle. So I'll put an arrow here to say this is the duty cycle. So for example, say we have a fixed period of time of 1 second and the power is on for the first half of that second and the power is off for the other half of that second, then we would have a duty cycle of 50%. Okay. And then, you can have duty cycles that where the power is on for 100% of the time or 25% of the time. The way it works when we're writing the code for this is that we need to establish what percent of time do we want our 5 volts to remain on during a fixed period. In our code here, when we're working with pulse width modulation, the numbers that we use to determine that percentage will be somewhere in between 0 and 255. Okay, but now remember that the analog pins, the input on those things read somewhere between 0 and 1023. So here's what we do. This first line of code, we'll add, let's deal with the red value. Okay, our red value that we get, that will be equal to the red sensor value. Okay, and remember the red sensor value, before I add anything else, I'm not done with this, but the red sensor value, that is being read by what's plugged into the red sensor pin, or what we've designated, what we've called the red sensor pin, and what we've called the red sensor pin is what's plugged into up here, A0. All right, but anyway, that value that we get, we need to divide it by 4. So we'll put a / here. So why are we dividing this by 4? Because remember, this number is going to be somewhere in between 1023, and say for example, if we take the maximum number 1023 divided by 4, then we're going to get an output value of 255. To be exact, on the calculator, if you divide 1023 by 4, you get 255.75. But remember, we're using this is an integer value, so the 0.75 will be negligible when we're for this particular value. So that means that our red value, our red value will be some number in between 0 and 255. Okay, once this does this division here, and I need to do a semicolon. So I need to have my green value be equal to the green sensor value divided by 4, semicolon, and blue value equal to blue sensor value divided by 4, semicolon. Okay, now we are going to take let's add this. Let's go ahead and add this bit of code in here to be able to read what's happening. Is serial dot print. Okay, this is how we read, and we want is see, parentheses, the mapped sensor values. All right, and backslash T. Backslash T means tab, so when the red, green, and blue sensor values are being displayed on the screen, there's going to be a space in between each of those values, so it makes it easier for us to read. And that will be, oops, forgot a T up here. Notice that it changed to the correct color when I added the T. Print, we're reading what the red value is. Semicolon. All right, I need to do this. Print. Backslash T, green. Again, this part here is just so we can read it on the computer, but we still have a little bit more to go for the LEDs. Let's see, 0.print. And what are we reading here? Oh, green value. Finally, serial.print. Let's see. Slash T. And then blue. Colon. Okay, and then serial. Oops. Print. Blue value. All right, let me make sure I have this all correct. Oh, and I want this to be that's going to be the last thing that we're reading. So everything will, after this, it's going to start over. When it goes back through the loop again, it'll start reading everything else on a new line. So now, to finish this out, we'll have analog write. Okay. LED pin, comma, red value. All right, then analog. All right. Green LED pin, comma, green value. And analog, oops, right, blue LED, KN. Value. Boom. Okay. So now, all right, so let me make sure. Okay, let me explain this. All right, this function analogWrite requires 2 arguments, and the first argument is what we established as our constants in the beginning: red LED pin, green LED pin, and blue LED pin. That's up here at the top here. And these are pins 9, 10, and 11. These are outputs. Remember that we came down here and made those outputs. Okay, and those are going to that color shifting LED. And we also have the it needs the like an analog value, and that analog value is coming from what we've called red value, green value, and blue value. What are those equivalent to? Well, it's whatever's coming out of uh, the the red sensor value, which is that's something going into the analog inputs, A0 and A1, A2. But we have to take that number. We'll go back down here. Sorry, take that number and divide it by 4. Why? Because these the pulse width modulation requires a operates on a number scale between 0 and 255. And so by dividing it by 4, it will receive some number between 0 and 255. Okay? So this, what we have here is enough to to be able to read or test these photosensors out and test our watch the color shift of our LED. So let's go ahead and get power hooked up.